Have you ever played beer pong, missed every shot and thought, wow, I suck at this game, I'm definitely getting blacked out tonight?
Well, I have. A few times.
But instead of practicing like a normal person, I grabbed a few motors, a joystick and a battery and built a turret that turns beer pong into a real-life video game.
Because if we nerds can't win with skill,
then we'll have to do it with absurd engineering.
So the idea is simple. Build a device that makes playing beer pong more about your brain rather than your motor skills, because I have none.
And a machine that actually gave me the inspiration for this project is what's commonly known as a turret.
A turret is basically a rotating platform that lets you aim something, usually a gun, in different directions.
You see them on tanks, battleships, video games, and very soon in beer pong tables.
Honestly, I'm very excited because I love projects with moving mechanical parts.
Watching plastic move on command is the closest I've ever felt to being like Tony Stark. So there are a few ways I can shoot the balls, like with a catapult or compressed air.
But those systems are either too limited or unnecessarily complex.
Something that I think would work much better though is using two rollers like a baseball pitching machine.
That way I can control the speed at which the ball gets launched, and I can build it using two tiny DC motors. I will first test how well I can control them using this little motor driver called DRV8833. It can power two motors at the same time, which is great for keeping the build as minimal as possible.
So I wired up a circuit with a potentiometer to control their speed and a button to flip their direction. And even though I need two Arduino pins to control each motor, I'm using just two in total because the motors will always run at the same speed.
Okay, so as you can see, the more I turn the potentiometer, the faster the motors spin. And if I press this button, they start spinning the other way around. And it's all thanks to that little guy right there. Cool, so now we know that when you connect motors to a motor driver, the motors spin.
This is what I came up with for the launcher's design. It will have two openings down here for the motors as well as hidden side channels to pass the wires through the axis of rotation.
That's actually the most elegant way to route wires in a project with moving parts.
They'll never get pulled no matter how much this thing spins. If I had them coming straight down, the launcher would yank them every time it moved. The rollers will be covered with sleeves and attached to the motors using fittings made from flexible 3D printer filament, or more commonly known as TPU. Behind the launcher there is a small platform to manually feed the ball, and a relatively long barrel to shoot it with precision. The distance between the rollers is 39mm, just slightly smaller than the 40mm diameter of a ping pong ball.
Now, this is just a static 3D model that I designed based on my intuition, which is usually trash, so I'll have to print it to see if it actually works.
I divided the main body of the launcher into 4 parts, printed them in silver filament, and put them together momentarily with hot glue. Then I printed the rollers, the sleeves, and the fittings, assembled them, and attached them to the motors.
Okay, so test number 1 of the launcher. The objective is to get the ball launched. Okay, let's see. That was very underwhelming. I think that the problem is that there isn't enough friction between the rollers and the ball. And we can test it if we put it just at like max speed. Yeah, we need a bit more squish between the rollers so they can actually transfer speed to the ball.
So to fix the problem, I narrowed the launcher's body to bring the rollers closer together.
Honestly, I'm kinda glad it failed because it gave me an excuse to add this hole in the middle, which makes it look cooler and reduces the overall weight of the design. So it's a win-win.
And using hot glue to attach the barrel was a good call because I can now just reuse it.
Okay, so test number 2 will be hitting that wall at a reasonable speed. I really hope it works. Oh great Lockheed Martin Overlord, please grant me your divine powers of projectile motion. No!
At this point, I was contemplating jumping in front of a bus.
Luckily though, I was able to figure this out after a week of designing, 3D printing, testing, repeatedly, multiple times, until I was able to find a configuration that made launching the ball possible.
First, I reverted the size of the body to increase the gap between the rollers, because when it's too close the motors just stall. Also, instead of using TPU sleeves, I wrapped them in heat shrink to improve grip, and oh boy, did that make a difference. Look at how they shot the ball before adding the heat shrink and after. You also probably noticed that I included an automatic feeder using a servo motor, because feeding the ball evenly turned out to be critical for consistent launches. Finally, I changed the barrel for a platform. Since the rollers are not perfect, they give the balls a tiny bit of spin, so when they randomly smack the walls of the barrel, they either fly out weak or rocket across the room. With the platform though, the ball leaves much more consistently. So after testing that the design was reliable, I routed the wires and superglued all the parts.
Alright, so we've got a solid launcher. Thank you, Lockheed Overlord! Now it's time to figure out the aiming mechanism.
The turret has to move in two axes, Y to set the parabola and X to swing side to side.
And since the build has to stay compact, I'll have to use small motors, and that brings up two key problems.
First of all, small motors are usually not very strong, which means that we shouldn't connect them directly to the axis, so we need to use gears to increase torque.
Second, we need motors that are easy to control and that are not super fast either.
For the launcher, it made sense to use DC motors because the ball had to gain a lot of speed.
For aiming though, we just need something that's precise. Like imagine if the axis made a full rotation in like less than a second. That would actually make aiming very difficult. So by analyzing these challenges, I can determine that the best motor for this job is a servo.
The difference between this one and the one I use for the feeder of the launcher is that this servo can rotate continuously, while the other one can only rotate 180 degrees. Now check out this awesome design for the Y-axis that I basically pulled out of my ass. I started by creating columns to hold the launcher. One of them holds the side with the gear and the other just serves as a support. Both of these have bases to connect them with the main platform, which is where the servo will be located. You can also see these little boxes with rectangular holes. That's where I will place limit switches to know when the launcher is at its minimum and maximum positions.
Adding these switches is actually very important if we don't want to destroy the system.
Unlike 180-degree motors, continuous rotation servos have absolutely no clue on where they're positioned.
Without limit switches, we could accidentally keep moving the launcher until it reaches its limit and hits the base. This could damage the plastic parts or even the motors.
Anyways, with all of that said, it's now time to go back to the scariest part: 3D printing everything and seeing if it actually works. I started by fitting the limit switches into their compartments and securing the bases of the columns on the main platform. Once that was in place, I glued the large gear onto the launcher and routed the wires through the columns before sealing them with their covers. With everything ready, I squeezed the launcher between the two columns and glued them to the platform, letting the launcher spin freely around its axis. To finish it off, I mounted the servo motor and locked its gear into position.
This was definitely easier than building the launcher, especially since gears are pretty straightforward. Like if these two gears are interlocked and this one moves, then this other one has to move too, right? Well, let's find out. So this button should rotate it up and this one down, okay? This is so cool. If we launch it, just to give you a closer look. Oh yeah, this is so awesome! And the limit switches are working perfectly because like once they press it, the servo stops moving, so that's good. So with that done, I can now focus on the X-axis. And since the mechanism will be exactly the same, gears, a servo motor, and limit switches, we know that nothing can go wrong. I probably shouldn't have said that.
So, I connected the bottom of the Y-axis platform to another platform with a gear to rotate the entire structure. To keep it aligned while still letting it move freely, there will be a holder/collar wrapped around it, and limit switches on both ends. Under that, we'll have a base, which is where the servo motor will be placed. In this section view, you can see how the switches will get pressed once the X-axis reaches its bounds. For the assembly, I first glued the gear platform and covered the Y-axis column bases, which I should have done earlier, but I forgot. Next, I glued the switches onto the holder, which I printed in two pieces, and set the whole thing in place. I then attached those two pieces, and therefore the entire device, to the base. And look at that, the X-axis spins pretty well. Finally, I set the servo motor in place.
I modified the circuit so it now allows me to control the new axis in addition to the previous one. Okay, retesting Y-axis. Okay. And now testing X-axis and launching the ball. I gotta be real with you though, controlling this thing with buttons sucks. And since the whole point of this project is to make beer pong feel like a video game, what better way than with a joystick?
They're very easy to add to any project because they're basically just potentiometers. Whenever you read their output, it's just numbers between 0 and 4095. That range basically maps ground to whatever maximum voltage you're fitting in. So you just assign those values to left, right, up and down. That's it.
I still kept a single button for launching the ball, but now the turret's rotation is entirely joystick controlled. Yep, definitely much better than using buttons.
Obviously I cannot leave these things hanging, so I also designed, 3D printed and assembled an enclosure for them. Looks pretty cool, right? Especially with this sleeve that hides the cables.
It seems like we're almost done. The only thing left is to build the unit where the controlling circuit will be placed. Obviously, I won't be using this breadboard because besides the fact that it won't fit, this is only good for prototyping. And since I'm a big boy now, I need to condense this entire circuit into a small PCB.
In case you don't know how that works, you basically just draw the circuit on your computer, lay out all the traces, send it off to the cheapest Chinese manufacturer you can find, and then pray you didn't screw up a single connection. After a few days, it arrives at your doorstep and you evaluate it like a true engineer by staring at it and saying,
"Yep, the PCB is made out of PCB. There's really no way to spot a mistake unless you solder the components and test it."
And the way I'm gonna do that is by using a hot plate to melt solder paste and a stencil to apply to the board.
When I ordered the PCB, I thought that the stencil would be around the same size. So imagine my face when I opened the package and saw this. What the f? This thing is the size of my cutting mat. Apparently, manufacturers send them like this unless you tell them to cut them out. Good to know.
After doing some magic trying to align this huge stencil with the PCB, I applied the solder paste and placed the components. We have an ESP32 microcontroller, a 3.3 volt voltage regulator, an FTDI programmer, and a few SMD resistors and capacitors. Once I turned on the hot plate, the solder paste began to melt once it reached a high enough temperature. The process was almost perfect. There were just a few solder bridges I had to remove using the soldering wick. Finally, I soldered the motor driver with an iron because it's a through-hole component. Now it's time to see if everything actually works.
First, I will connect the board to my laptop, and if the laptop makes the doo-doo sound, then that means that the programmer chip was soldered correctly. And now I'm going to power on the ESP32 to see if it prints its boot up info on the serial monitor. That will mean that the microcontroller was also soldered correctly, so let's see. Okay, and... Yes! Yes!
I am Jose Mourinho.
With that out of the way, we can now finish up the build. And I won't show the 3D model of the base, so you can see how it ends up looking without any spoilers. Let's do this.
First, I hot glued the USB-C connector and the power switch to the center section of the base. Then I super glued translucent covers all around it, which are going to help diffuse some sick LEDs later. After that, I screwed in the top part of the base so I could start adding the electronics. I hot glued the battery and charging module in place, soldered their cables, and did the same with the voltage booster and the main PCB. I screwed the turret to the base and soldered all the turret's cable to the board. Then I passed the joystick wire sleeve through the back opening, locked it in with some hot glue, and soldered its wires too. As you can see, I had to solder an improvised wire directly to the ESP32 because I connected one of the joystick's axes to a pin that can't read analog values. Yes, I know, I'm dumb. Anyway, with everything wired, I uploaded the final code to the ESP32. Now let's move on to the lighting. I placed LEDs around the center of the bottom plate, secured them with hot glue because their adhesive is garbage, and added a small spacer on top to keep cables out of the way. Finally, I soldered the LED cables to the PCB and screwed the bottom part of the base to the rest of the assembly. And that's it, the beer pong turret is complete.
Now, I'm obviously super eager to test it, mainly because I just want to make sure it doesn't just blow up. But before that, let me explain to you how this thing works.
To turn it on, just flip the switch on the back. The first thing it does is show the battery level by lighting up the LED ring according to how charged it is. Right now, it is fully charged, so it completely fills it with green. Immediately after, it will do a homing sequence by going all the way to the left, then right until it approximately reaches the center, and finally it completely lowers the Y-axis. Once that's done, the ring will turn light blue, meaning that the turret is ready to be used. To move it, just use the joystick. The response is immediate and the movement is super smooth. Also, each direction has its own specific color, and you can even see when the turret automatically stops moving once a limit switch is hit. When you've locked onto your target, hold the button and move the joystick up or down to select one of the 3 speeds. The brighter the red light, the stronger the shot. Once you're set, just release the button to launch the ball. Yeah, it's actually really simple to control, so anyone could use it. Oh, and before I forget, to charge it, just connect a USB-C cable and wait for the indicator LED to turn blue.
Now, I don't really have a beer pong table laying around, so I put everything on my kitchen's island. It's not as long as a beer pong table, but it should be good enough. Okay guys, let's play some beer pong. Gonna go center first, full throttle. Okay, that was a little bit too hard. The trick here is the positioning. If it's going too far, that means that the Y-axis is too low. We have to... Maybe I am trash at this game, no matter what I do. Yes! Yes! This is all about analyzing. I'll take it. Ooh! Again. Yes! Yes! That was the hardest shot. That was the hardest. Oh, this is definitely more fun. I think I'm getting the gist of it. 6 to go. Ooh. Yes! That was pathetic. 4 more to go, and I'm gonna put it in a diamond position. Yes! I don't even know how many shots I've done so far, but my K to D ratio in this case is probably much better than my real life one. So far it's been an improvement. These two are probably gonna be the most difficult, I don't doubt it. So let's see if this shot goes, and if not, I'll do something else. Actually, this is the last. This is the last. This is the actual last. Yes, no! Okay, you know what? For these last 2 shots, we're going to play a new game I just invented called beer pong bowling. The point is just to clear them away with full throttle shot. Okay, just one more to go. Yes! Not gonna lie, that was really fun. Even though the turret isn't super precise, you kind of get the trick of it after a few shots. And that beer pong bowling game, that has lots of potential. Maybe I should patent it. Now, if I want to confirm that this is definitely an improvement from regular beer pong, I need some beta testers. And I will make them play a different version of beer pong that I believe will be way more fun. In this version, they will be able to use all 3 launching speeds without being constrained by the length of the counter.
So, I invited Natty and Jack to try my invention. They're my best friends.
Literally, I just met this guy. He's paying me $20 to test this video game.
What? You were getting paid?
So after I explained my buddies how the turret worked, we jumped straight to the game.
Alright, so there are 45 cups in here, and the goal is that one of them has to get to 10 cups first. Oh! Ooh! First one. How are you feeling?
It's okay.
Seems like she's gonna kick your butt, bro. Alright, so we're gonna put the cups here. Right means Natty, left means Jack.
And PlaciTech drinks.
Yeah, no!
Before I go, put in the comments if you want PlaciTech to drink every single one that we've made.
No. Ooh! What do you say?
There's something wrong with this ball. It drifted to the right.
Excuse.
Yeah, exactly. Losers always say that. Ooh! Wait, which one did we get?
Oh, there we go.
Ooh!
That's going to Mars.
Ooh! 4-2!
The lucky bounce!
Ooh! And double bounce. Ah, sorry ass shot.
I let that go back.
Sure you did.
You know, I wonder why you guys don't point it like here.
No, I feel
Tried,
like
it
that
went
one
that
is
way.
like...
You have to point it then there so it
I
goes
prefer
here.
to go like center, you know?
Maybe build it so it goes where you want it to.
Okay, so we're gonna switch up things a little bit. Now they're gonna launch the balls from that side. Oh! And that was the first one.
First one.
Yeah, this is the angle. This is the angle.
Right, 5-4. That is just that you need to take into consideration the rotation of the Earth. So,
Yeah, of course. We're not all blessed with your beautiful mind.
What did you study?
Industrial engineering.
Oh, okay, no, I'm not the engineer.
Don't worry, industrial is not a real engineering.
It was.
Oh! 5-5.
This controller is cool, by the way.
I made it.
Really?
Okay, Jack, if you don't get any, then we're switching up things a bit.
Don't worry, I got you.
Ooh!
I am Jose Mourinho.
6-5. We need to get to 6-7. Right now it's still 6-5. Okay, so what we're gonna do now is that you're gonna play a game that I invented called beer pong bowling. Bro, how do you miss that? Oh, 6-6. Damn! Holy shit! Huh?
That's it, yeah, no? Or no?
No, he's like 9-6. Bro, you fucked up the 6-7 meme. Nice! Ooh! 9-8, right?
9-8.
9-8, oof. Ooh! 9-9. Ooh. No, but it's like by 2.
By 2.
You got
Yeah.
2?
Yeah. So it's like 10-9 right now. Ooh. Right now you're tied, right? You're 10-10. 10-10, yeah. Come on. Bro, there are only 3 speeds. Hey, GG. So, Nati, what did you think of the game?
I think it was so much fun. Definitely the bowling one has a lot of potential.
Awesome. What about you, Jack?
The game is rigged.
No.
PlaciTech made it so he can get more female viewers.
What? No.
Not only that, the game had no sort of skill. All luck. You just bounce it in. PlaciTech is a genius. He's the smartest person ever. Best game ever.